Okay, so I've started the recording and we can look at what we have for today. So there is this data that I've shared with you, and it's a wine data set. And this data set has some flavor characteristics. So these are the ingredients that we have in a specific wine. And from these ingredients that we have here, or from these characteristics that we have here, we want to group these wines into maybe distinct groups. So you can see we have the alcohol level, the malic acid, the ash level, ash alkalinity, magnesium. Then we have the total phenols, we have the flavonoids, we have the other characteristics that we have for these wines. But we don't have something like maybe let's say a quality column here. So how will we rate the quality of this wine based on these characteristics that it has here? So what we want to do is we want to create a machine learning model that can be able to like produce this quality column, and that will be the aim of today's class. And that will be the practical approach as to how we can handle k-means and maybe any other clustering algorithm that we have out there. So let me close this. Then what I'll do next is I'll upload this data to GitHub. So I believe most of you will already have access to this data, but I'm uploading it to GitHub. So let me upload it here. So for those who don't have the data downloaded yet, so you'll have to get it here. Then I'll open that and then I'll click on Pro. So I guess I can copy that link. Then what I'll do is I'll create a new notebook for today's class, and that will be wine clustering notebook. Okay, so we have that. So the first thing we usually do is we import libraries. So I'll do that. So we will have libraries importation. I'll start by importing pandas. Then I'll import NumPy as well. I'll import matplotlib, then Sequon. Then lastly, I'll import warnings, and we can ignore all warnings. Yes, so we have that. Then the next step is to import the dataset. So I'll have my data being equal to pd.read CSV, and then I'll paste in the link there. And then we can have data.head. So let me share that link with you in the chat section, and then I'll give you around 5 minutes to set up your notebooks. And okay, let me check my audio. Can you hear me well? I guess I'm audible and you can hear me now. Okay. So if it's better now, I guess we can proceed. So I'll give you guys 5 minutes to work on this, and then we can proceed. So first start by importing the libraries, and then using the link that I've shared, go ahead and import your dataset. So most of the time I'd prefer uploading my dataset online and loading them from links rather than storing them on my PC. Because issue is when you store the data set on your PC, chances are you lose it and you might have troubles uploading them again. So at 8:14, we will proceed on and maybe start our EDA. Okay, so 5 minutes are over. We can proceed. So these are the characteristics that we have in our data set. And what we can do is we can go ahead and check if there are any data issues in this data set that we have. So one thing you should note is for most of the columns, we have values that are quite low. So maybe less than 20. But for the proline column, the values are quite high. So they are at the 1,000 mark. So the first thing I'll do is I'll check if my data has missing values. So I'll do data.isNull.sum. So my data is good. So it has no missing values. And the second thing I'll do is I'll check for duplicates. So I'll have data.duplicated.sum. So the data has 0 duplicates. So this is good because it means the data is clean and we can work with it as it is. So 2 minutes you work on these 2 code cells and then we can proceed. So I guess you should be done with this part. So we will move on to the next part. And what you guys were asking is about outliers. So we are going to do some EDA here. So I'll add a heading there. And we are going to check our data distribution. Or let's say check for outliers. So check for outliers, what we usually use is the box plot. And that's basically what we will do. So I'll type in here data, then box plot. Then I'll have to drop this column here. So the proline column, because it has values which are quite large and it might affect how we maybe see our box plot. Then axis should be equal to 1. Then I can type in something like sns.set, because we can use a white grid or let's say a dark grid. Okay, let's run that. And this is what we get. So for most, I guess we don't have outliers. So instead of us using such kind of plot, so what I'll do is how many columns do we have here? So I want our work to be a little bit clean. So I'll check the number of columns. So we have data.columns. Okay, then I can type in something like len, get the number of columns we have here. So we have 13 columns. So what I'll do here is I'll create a grid. Okay, so for 13, what number would work? Okay, let me do something like 13 divided by 4. Okay, so create a grid of maybe 4 by 4 plots. So we will have plt.figure. Then we are going to have our axis, and then figure, and then we are going to have those subplots. And then we are going to plot our box plot for each variable. So here we need a x1, x2, but I guess a for loop can work. So for variable, then subplot in zip, then data.column, fig.flatten, then you get the box plot. Then we can add our labels. And I can run this to confirm if it works. Okay, so it's not working. So I'll just type in AX box, then 1 0 tab that 1 1 1 2 1 3 2 0 2 1 2 2 2 3 3 0 3 1 3 2 then 3 3 0 0 0 1. Okay, so I'm basically repeating some few columns here. Okay, so we have an error here which I'll have to fix. So let me find some resources for this. So at times when you're stuck, you just have to go to the documentation website. So I'll go to Matplotlib, then I'll open that. Then what I'll do is I'll click on examples. Then we have this example here, for example. Yeah. And this is what we have to do. Okay, so let me redo my code. Okay, let me try find another example that we can use for these plots that we are doing. So this is the subplots part. We can specify the number of rows and we can specify the number of columns. Then here we have to specify all those axes that we need. And then when we are plotting our data, then we have to specify the plot here. So it's the same way I'm doing it. So let me go back to the box plot part, and then I'll copy the code for box plots there. Okay. Error alcohol. So I guess I know where the problem was then. Yeah, so let me fill this now and then we can proceed. So I'll get the column names that we have here, and then we can fill them down here. So that's alcohol, that's malic acid, and then we have ash. So I guess it's just changing the first column name. Then ash alkalinity. So let me finish this and then I can share the code with you. So I'll give you more time to work on these subplot. Okay, so we were here. We have the magnesium part. We have the total. We have the flavonoids. Then we have the non-flavonoids. Okay, let me run that first just to confirm we have everything okay. So I'll just have to type in plt.show. Yeah, so we have our figure, we can increase its size. Okay, so that's okay. Let's proceed. We have the color intensity, then the hue, then the OD to 80, and lastly we have the proline. So here I'll increase this size to something like 30 by 30. Then I can run this again. And here I guess we have our box plot. Then we have plt dot, let's say, tight layout, confirm if we can see everything. So still we are not able to like see everything clearly. So what I'll do is I'll just use a for loop instead. So I'll just create a for loop to plot the box plots. So here I'll have for I in column data, then plot the box plot. So this will be much better. Then we can have plt.title I. Yeah, so that's much more better. Let me delete this so we can just go with this simple thing here. So let me share the code with you and then we can proceed. So you see, when you are working with data that you've never looked at before, you get some challenges. So you have to think of ways in which you can visualize your data and maybe come up with visuals that you can be able to like extract insights from. And here a for loop would work more better rather than creating a whole plot which has everything in it. So this is our plot. These are our plots. I'll give you 3 minutes to copy this code and then we can proceed. So we can explain what we have in these plots. So we can proceed. Let me explain what we have here. So if we look at the alcohol column, we have the minimum value below here at 11. We have the maximum value at around 14.9, 15, and most of the values are between 12.5 and 13.5, something like that. And in here, we have no outliers. So for malic acid, this is the distribution. So we have some outliers up here, but we can disregard them because they are quite small. Same for ash, we have, I think, two outliers. Then ash alkalinity, we have two outliers, three. Then for magnesium, we have some outliers which go further up. Then for total phenol, we have no outliers. For flavonoids, we have no outliers. Non-flavonoid, we have no outliers. Then for these, no outliers, some few outliers. For color intensity, some few outliers on the upper side. Then for hue, some few outliers on the upper side. So you can investigate them later on if you get a chance. So this is the distribution of the data that we have here. So the next thing I'm going to do is I'm going to check the correlation between these columns because I want to see if if in a way they are correlated to each other. So correlation. So I'm going to have my correlation being equal to data.core. And to actually see it better, I'm going to create a heat map. And I'm going to create a figure first. Then I'm going to create a heat map. And then I'm going to annotate this heat map. Then for the CMap, I like using Viridis. Then we can have plt.show. And if I run this is what I get. So the figure is quite big. Let me reduce its size. But I guess I'm zoomed in much for me to like complain about the size of that figure. So should be okay. So this is the figure that we have. Okay, so go ahead and plot this and then we can discuss. So as a bonus, you can also create a cluster map. So I'm going to create a cluster map here to see which columns are closely related to each other. So we're going to have sns.clustermap, and then this is what we have. So go ahead and copy these two codes, and then we can proceed and maybe try look at the trends that we have in this data and the relationships that we have in that data. So Seaborn is the library that I like using most of the time when doing visualizations because the visualizations always come out looking good without us having to like work more on it. So this is just something I'm trying out as you are copying this code. So 5 minutes. So at 8:39 we proceed. So you don't have to copy this code that is up here. So it's something that I'm just testing. So I think this will be much better when checking the correlations. But this is something you'll check on later. So I just remembered we could create something like this. But for now, we'll just use this, and maybe I can use this for the explanation. Okay, so you should be done by now. Let's look at the results that we have here. So I'll do that using this table that I've created up here. Let me try change the color and see if I'll get something even. So I'm using a similar theme that I have down here. So if you check this table, you'll note that majority of the columns that we have here are not that much correlated to each other. And for example, columns that are highly correlated to each other are maybe the proline column and the alcohol column, and the color intensity column and the alcohol level column. So those are the only two columns that I will say are highly correlated to each other. And maybe the OD to 80 and the total phenols and the flavonoids. So the total phenols and the flavonoids are highly correlated with these lower columns that we have here. And we can't really go into maybe deeper details on that, as we are just looking at the top PDA part. So when you are free, you can go ahead and extract more insights from this table that we have here. So we've checked the correlation. So let's again check the cluster map. So for the cluster map, you just change this part here where you've written heat to cluster. And if we check the cluster map, we can maybe see columns that are related to each other. So, and from this cluster map that we have here, we can actually decide how many groupings we can create for this data set. So for me, I will say, for example, from this tree, so it's like a decision tree, but we haven't discussed decision tree in class. So it's like a decision tree whereby we are looking at the correlation between these columns that we have here, and we can decide like how many groupings of this data should we have. So if I maybe, so down here where you see me hovering my mouse, I can say that this data is suited for 3 distinct qualities of alcohol. And we'll get to confirm that once we run our model. You can see we have these 3 on this side, we have this one on this side, and we have this one on this side. So we have 3 major groupings from this cluster map that has been created here. And from the characteristics that we have here, if we look up here, you can see, for example, the malic acid, ash alkalinity, and the non-flavonoid phenols are categorized to be in a single group. So you can see here. So these are a single group of columns that determine the quality of the wine that you have. And then we have this part here where we have 1, 2, 3, 4, 5. We have these 5 columns. We have the hue up to the flavonoids column, which are a second grouping of the characteristics that we have for a given wine. And then we have this last column here, which has the magnesium, alcohol, proline, ash, and the color intensity grouped together. So those are the 3 groupings of the characteristics that we have in our data that we can use to determine the quality of wine that we have. Okay, so you'll go through these in later on and maybe get to extract more insights. And actually, if you have access to ChatGPT, I guess you can also use it to like explain these outputs that you have here. So since we've checked the correlation of our data and maybe the distribution that we have for our data, the next thing we'll do is we will create our model. And this is the modeling part. So already we know that our data does not have like any categorical values. So it's all numeric. So what we will do here is so I'm going to teach you a new concept today. So we will scale our data. We will scale the data. So as we checked earlier, we saw that the proline column had values that were quite big as compared to the other column. So we want our data to be in a similar scale. So what do we do? So we scale the data. And what model will we use? So we will use standard scaler. We can use min-max scaler, but I will suggest we use standard scaler for today. So what we do is we import, so from sklearn.preprocessing, import standard scaler. And then we will have our scaler being equal to standard scaler. And then we fit and transform the data. So we will have scale data being equal to scalar.fit transform the data. And then we can check our So let's convert the scale data to a data frame. So we will have a scale data being equal to pd.data frame, then scale data, and then we get our columns from the original data. And then we can check our scale data head. So this is what we have now. So all values that are in here are in a similar scale. So if we do, so instead of checking scale data dot head, we can do scale data dot describe. And you can see for all the columns that we have here, the max value is around 3 or 2, and the minimum value is at -2 or -2. So all these values are in a similar scale now. So we can work with it even more better when fitting our model. And remember, when we were studying k-means, we mentioned that the k-means model works based on distance. So if some of the values that you have in your data are quite large and some are small than what you have in other columns, you will have issues fitting your model. So I'll give you 5 minutes to copy this and then we can proceed. So I'll comment this out. And as you are copying that, I'll just create a sample scatter plot. So I'll create a scatter plot between column 0 and 1. So I just want to see what kind of plot we will get. So plt.show. So this is our scatter plot without any labels. So yeah, we want to group these data into some groups. So that's what we have. So 5 minutes, you work on this. So at 8:52, we will proceed on and maybe fit our model. Okay, so we can proceed. We've scaled our data. So the next thing we will do is we will create our k-means model. So remember when I had informed you that this data will fit maybe 3 clusters from these plot that we have here. So I'm going to fit a k-means model with 3 clusters. And then once we end the class, I'll show you a better way of determining the number of clusters that you need in your data. So let's fit the k-means model. So I'll go to yesterday's notebook, class notebook, and so it should be, which one should it be? So it should be this one here. So k-means clustering, not that one. Should be this one here. So I'll copy this part for the model, and we will have the number of clusters being equals to 3, and then I'll fit my model to the scaled copy. So I've copied this from yesterday's class notebook. And then what you can do is you can create your data labels. So here we will have our scaled data, and we will add the labels column. And then after that, what I'll do is I'll replot the scatter plot with the new labels. So we will have scale data.ilog, and then the color should be equal to the created groups. So let me run this. So we have our model fitted, we have the created groups here, and then I can run the scatter plot. So plt.show. Okay, so here I'll have to choose the color palette. So palette 1 should be okay. Okay, so let me change this to SNS. And this should be the hue. So my X should be equal to that and that. So I'm getting an error here. So I'll just give you time to copy these first, and then as I'm working on the scatter plot part. Yeah, so 5 minutes, you copy this part for the labels creation, and then I'm going to create the code for the scatter plot part. Okay, so I've lost that. So you have that. Okay, so everything should be good now. So you have 3 more minutes to work on this. Let me share the code also in the chat section. And then I'll explain what we have here as our output. This is the updated code for the scatter plot, and we have it here. So I'll give you 5 more minutes to work on this because I guess the time I've given you is quite short. So at 9:03, we will explain what we have here as our output. Okay, so I guess we can proceed. Let me rerun this, and this is what you see. So for example, if we take the malic acid column and the alcohol column, so from the scatter plot that we had up here, so we have these distinct groupings that we have here, and we have these three dots. So these are the centroids that the model has created. And you can see for each centroid, we have data points allocated to that centroid. And depending, so based on the characteristics that we have, maybe the alcohol characteristic, the malic acid characteristics that we have for that individual data points, we have these three groupings. So if you were to present these results to someone who is maybe interested in knowing what affects the wine quality, so what will you do? So what I will do is so let me rescale the data. So I'll rescale the data to its original form. And then what I'm going to do is I'm going to get the mean and maybe the median values. So we will have the unscaled data being equal to scalar dot inverse transform. So that's how we rescale our data. And then we convert the unscaled data to a data frame. So I'll do this first because I guess our time is over, and then you'll check these once we ended the class. I'll convert the unscaled data to our data frame again, but there is an issue here. Okay, so I'll have to drop the created groups column here. And then once I've converted the unscaled data, I'll add the labels again. So we have that. And then what I'll do is I'll get the mean and the median of the groups created for each column. So that's what we have. So we get the unscaled data, and then we group by created groups, and then we aggregate by mean and median, then we transpose. Okay. So if you look at these, you'll get to see some few trends. So for example, if we check the alcohol column, we can see that the mean for group 1 is at 12.25, which is at the lower end. The mean for group 2 is at 13.13, which is at the mid. And the mean for group 2 is for 13.67, which is at the upper end. So if we go to something like Prolin, you can see for quality 0, we have values at 510. For quality 1, we have values at 619. And for quality 2, we have values at 1100. So definitely there is a way that these splits have been made. And you can see the trend is not always similar for all the columns. So if we check for OD280, so we don't have groupings based on the rise of the number that we have or based on the value rising. So you can see for OD280, group 0 has the value 2.80. Group 1 has the value 1.69. And group 2 has the value, the mean of 3.16. So these groupings are based on the trends that we have in these data. For example, for color intensity, we have 2.97, then 7.23, then back down to 5.45. So it might not be same in all instances. So here you can, based on these statistics that we have here, you will know that for a wine bottle that has these characteristics that are maybe in these, maybe group 0, you will maybe rate them as quality 0. Those that have characteristics that are close to group 1, you will have it as a wine data set in group quality 1 and then group quality 2. And basically that's how you can also group customers That's how you can also group maybe attacks in a network system, whereby you just check at these statistics that we have here. And yeah, that's how we apply k-means in the real world. So you'll copy this code once we are done with the class. So I'll share the notebook. So another thing we will do lastly is I'll show you. So how do we get the best k value? Okay. So what we do is we create an elbow plot. And where you see, so the reason as to why I'm saying we create an elbow plot is because where we see a bend in this plot, that's where our optimum value should be. So I'll create an empty list with the inertia values. So these inertia values will be these number of clusters that we have here. And then what we will do is we will create a for loop that will run k-means for each value that we have. So we will have for I in range 1 to 11, for example, you fit a k-means model to that I, and then you append these value there. Then what we do is we plot the inertia value, and then from that inertia plot, we can get to like know which is the optimum value for our k-means model. So here you can see this is our elbow plot, and you can see we have a bend at 0.3. Okay. And I guess there is a way in which we can highlight that elbow bend. So I guess I'll do something like highlight the elbow. So we can have something like plt dot, but this should be hard to highlight. So you'll just have to like use your eyes to see what's happening here. So we extract the inertia values from our k-means model. And from these inertia values, where we see a bend, that's where we choose the best number of k's, because this is an elbow plot. And that's how you choose the best value of k. I guess that should be in the Notion notes that I shared, but you'll get to try it out later on and see the results for yourself. So that brings us to the end of today's class. So it has been long, but at least we've looked at how we apply one of the ML models that we have here. So for upcoming models, we will be discussing the model. So we will be seeing how we maybe create the model, how we run and fit it. And then in the next class, we do a sample project where we use that model on a real world data set. So this is our first project for today. So you can replicate it and use it in your portfolio. So that's all for today. So I'll stop the class recording.